In this video, we're going to derive the distance and midpoint formulas. But first, let's make sure we're clear on exactly what these formulas are. The distance formula allows you to pick any 2 points you want in the Cartesian plane, any 2 points you want. It doesn't matter how they're oriented relative to each other, if they're above or below the x-axis or to the left or the right of the y-axis. It doesn't matter. Any 2 points you want. And with the distance formula, you can calculate the straight line distance between those 2 points. Now, with the midpoint formula, you can once again pick any 2 points you want, and the midpoint formula will allow you to calculate the coordinates of the midpoint of the line that connects those 2 points. Okay, and so, but what's the purpose of learning these formulas? Okay, well, as we've talked about, we're going to use coordinate systems, these devices that fundamentally are used to map out points in space. We're going to use this as a visual aid for visualizing and analyzing relationships between variables, where in a lot of cases, the actual variables have nothing to do with actual 3D space. But even so, it's still valuable to be able to understand how to do different types of analyses with the coordinate system, such as finding the distance between 2 points and finding the midpoint location between 2 points. Again, even if the variables that are represented by the axes have nothing to do with actual 3D space. Okay, now, another thing to note is that, as I mentioned, these 2 formulas apply to a Cartesian plane. A Cartesian plane. Okay, so if we happen to have a plane mapped out with another coordinate system, like a polar coordinate system, then if we wanted to find the distance between 2 points, or the midpoint coordinates between 2 points, we'd have to use different formulas. And the derivation of those would be a little bit different. Okay, but you could still absolutely do this. So here's the distance between 2 points in the Cartesian plane. But just to show you the distance between 2 points in a polar coordinate system plane, if this point is r1 theta 1 and this point is r2 theta 2, then the distance d between these 2 points would be the principal square root of r1 squared plus r2 squared minus 2 r1 times r2 times cosine of theta 2 minus theta 1. And the midpoint formula in polar coordinates would actually be very similar to the midpoint formula in rectangular coordinates, where you're just taking the average of the 2 r values and the average of the 2 theta values. But there are some nuances to this that we'd have to talk about if we were discussing the midpoint formula in polar coordinates. But still, for any coordinate system, you can think about deriving formulas like this. Okay, but now, so let's derive the distance formula. So we've got this Cartesian plane here. Now let's pick 2 points in the plane. Let's say we want to find the distance between these 2 points. We want to come up with a formula that gives this straight line distance here between these 2 points based on the coordinates of the 2 points. So what we're going to do first is let's label one of these points as point 1 and one of these points as point 2. So it seems, we've got this point at the bottom left here. We kind of read from left to right. This is in more of the negative region, I guess. So let's make this point 1. So this has coordinates x1, y1, and this we'll label point 2, which means it has coordinates x2, y2. Okay, so now to calculate this distance, what we can do is we can use the Pythagorean theorem. And this is going to work great because we're dealing with a Cartesian coordinate system here, where all of the major and minor axes are perpendicular to one another. And the Pythagorean theorem is based on, it relates the side lengths of a right triangle. So if the two side lengths are A and B, and the hypotenuse is C, then the Pythagorean theorem states that the sum of the squares of the two side lengths are equal to the square of the hypotenuse. Okay, and so with that, what we can do is we can make this line here with length D the hypotenuse of a right triangle with legs as shown here. Okay, and we know that this is a right triangle because of we're dealing with a Cartesian coordinate system. All these minor axes are perpendicular. Okay, and so now all we need to do is figure out what the lengths of each of these legs are, and then apply the Pythagorean theorem. So, okay, to get the lengths of these sides, we can take advantage of the fact that this side length is based on a pure change in x coordinate, and this side length is based on a pure change in y, or y coordinate. So it's this side length is just the difference between the x coordinates of the 2 points, and a similar idea for this side length in relation to the y coordinates of the 2 points. So now to make the side lengths positive, let's subtract x2 from x1, since x2 is more in the positive x direction than x1. So this side length is x2 minus x1. Okay. And similar idea here, this side length is y2 minus y1. And so with that, we can write out the distance formula using the Pythagorean theorem. So the distance D is so you've got x2 minus x1 squared plus y2 minus y1 squared. Okay, now, but we're not done, because we have to think about different scenarios. If we're trying to keep the side lengths positive, then whether or not we use y2 minus y1 and x2 minus x1 for the side lengths is going to depend on factors such as which point do we choose to be point 1 and point 2. We have to come up with some rules for how to choose which point is point 1 and which point is point 2. But even more than that, this could also depend on, what if you have points in a different orientation? You have a point in quadrant 2 and quadrant 4 instead of quadrant 3 and 1. Well, okay, the first thing we can notice is that we can take advantage of the fact that since we're squaring these two lengths, then it doesn't matter that there's no difference between, if you have x2 minus x1 squared, that's going to be equal to x1 minus x2 squared. And same idea with the difference between the y coordinates. And because of this, because of these equalities here, what we would find is that it actually doesn't matter which point we choose to be point 1 and point 2, or what the orientation between the 2 points is. The result is that in all scenarios, for any 2 points you pick in the Cartesian plane, no matter how they're oriented relative to each other, you can choose either one of those to be point 1 or point 2. Apply this formula, and you're going to get the magnitude of the straight line distance between those 2 points. This is going to be a positive magnitude here, because you're going to have a positive number under this principal square root, which is going to output a positive number. And so that's it. This is the distance formula for the Cartesian plane. Okay, now, what about the midpoint formula? So once again, we're in this Cartesian plane here. Let's start by, let's pick 2 points. Let's have one more in this bottom left negative region, and the other point more in this positive, this upper right positive region, just to start off simple. Okay, and so the midpoint formula is, what we're wanting to do is find the coordinates of the midpoint of the line that connects these 2 points. So it's something, somewhere in here. What's the coordinates of this point? Okay, so once again, let's choose this point to be point 1, since it's more in the negative region, with coordinates x1 and y1, and this point to be point 2 with coordinates x2 and y2. okay, the coordinates of the midpoint are going to line up with the x-coordinate of the midpoint of this leg of the right triangle and the y-coordinate of the midpoint of this leg of the right triangle. So if we look, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we go 5.5, okay, now here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. There is the midpoint. Now, what we're looking for, though, in terms of a formula, is the coordinates of this midpoint. So what is this distance and what is this distance? Well, what we can see is that if we take the average of the x-coordinates of the 2 points, then regardless of what the sign of x1 or x2 is, positive or negative, the result is going to be this coordinate. For example, if we do that here, we take the average of x1 and x2. So x1 is 1, 2, 3, 4, 5, 6, 7. So minus 7. And then x2 is 1, 2, 3, 4. Minus 7 plus 4 is minus 3. Minus 3 halves, minus 1.5. There you go. And we can do the exact same thing to get the y-coordinate. Take the average of y1 and y2. Now, but what's interesting about this is that based on the commutative property of addition, the order in which we add x1 and x2 doesn't matter. So this is equivalent to x2 plus x1 divided by 2. And so with that, then, the coordinates of the midpoint of the line segment that connects 2 points, we can just write as the x-coordinate is x1 plus x2 divided by 2, and the y-coordinate is y1 plus y2 divided by 2. And with that, just like the distance formula, it doesn't matter which 2 points you pick to find the midpoint between. It doesn't matter how they're oriented relative to each other. And furthermore, it doesn't matter which point you choose to be point 1 or point 2. It doesn't matter. Because with the distance formula, this freedom to choose whatever point you want to be point 1 or point 2, or the points could be located wherever you want, primarily came from the fact that you were squaring the 2 side lengths. Well, with the midpoint formula, this comes from the fact that the commutative property of addition makes it so that it doesn't matter the order in which you sum the x and y coordinates. And so there you go. That is the distance and midpoint formulas for the Cartesian plane.